Welcome everyone. Uh, Welcome to today's session. I'm so excited to introduce our speaker, Sandhya Vinjam, who has an amazing background in tech and leadership. Sandhya is currently Sandhya is currently a technical lead at DoorDash, where she is working on building and scaling critical systems. Before that, she was a software engineer at Meta, Amazon, and Nvidia. So she's no stranger to tackling big challenges at some of the world's top companies. Today, Sandhya is here to share her experience driving reliability in distributed systems, overcoming scaling challenges, and improving system reliability from 90% to an incredible 99.9%. She's got tons of valuable insights from her journey, and I know we are all going to walk away with new ideas and inspiration. Let's give a warm virtual welcome to Sandhya.
Thank you, Creator, for actually giving me this opportunity. And I will actually share my screen and then start presenting. Can you see my screen?
Yes.
Yeah. Okay. Is I kept it in slide mode.
Yeah, that's great.
Awesome. I will kick this off. Hi, everyone. I'm Sandhya, and I'm going to give this session on path to 99.9% leading high scale product, uh, 0 to 1 initiative, systems reliability. And like it also covers like at scale products. It majorly covers like how the guidelines are built to actually come up with the reliable products. And I'll kick this off. So here is the agenda. I'll go through my introduction and then my experience, and then I'll jump on to the importance of reliability and how it is like especially important in the sense of 0 to 1 products. And I'll go through some key principles and guidelines around reliability. And after that, I'll quickly go through how can we put some things to practice in your regular work. Like how do you build systems with reliability? And towards the end, we will do Q&A. So that's the agenda. Let's jump to the first part, introducing myself. Hi, I am Sandhya. I'm tech lead and senior software engineer currently at DoorDash. I have 14 years of experience in developing distributed systems at leading technology companies. At DoorDash, I'm currently working at DoorDash, and previously I worked at Meta, Amazon, and Nvidia. Especially Meta, I got opportunity to work on like tier zero, like priority zero, like critical infrastructural services. And throughout my career, I have focused on building like highly reliable services and components while solving like diverse business challenges across these organizations. In Meta is a a social app, and DoorDash is a delivery app, and Amazon is a retail business. Though I was working on like different business aspects in these organizations, my core interest was towards like how to build reliable systems and components. My professional journey has been shaped by excellent mentors that I had at different companies. I had like multiple mentors in each company, and for which I'm like deeply grateful, as it has contributed significantly to where I am today. So, what is reliability? So, let's talk about what exactly is reliability. So, the ability of a service or a system or a product to perform its intended functions consistently, accurately under specified conditions over time. It can be as simple as like you owning a backend service or you owning an end-to-end infrastructure for all the like for a mobile app. For example, it could be a Facebook app or DoorDash app. So it like no matter like how complex it is, it can be any system, service, or product. So the importance of reliability is you need to make sure it is actually working at different conditions. So sometimes they, like, you might see more users if you are running an app, sometimes you see more clients if you are running a service, but the intention of reliability is to still maintain the success criteria that you define in those conditions. And so the core importance factors for reliability are, it, like, why do you want reliability is the question, right? Like, what happens, like, you don't, what happens if you just don't care about reliability? So often, like, these are the important things which you might not get if you just ignore. Reliability brings user trust and business reputation. So if you are, like, consistently, like, not meeting the success criteria that you promise to your partners who are relying on your system or product, then you have, like, pretty bad reputation and pretty bad trust towards the end. And reliability issues create cascading like operational challenges. So it's like, if you don't fix your reliability, then what happens is, it's not like today it might appear just maybe one component of your big system is not working, but sometimes, like, eventually it might lead to cascading failures where the whole product or the whole company might go down. You might have seen, like, multiple incidents, like Slack going down for a few hours, like GitHub going down for a few hours. So those are the global outages that occur. The root cause might be, like, as simple as very, like, maybe null pointer exception, but null pointer exception emerged in just one component or one service within that, like, the mesh of all the services, but it's still, because of the cascading failures, it's going to impact the whole website or app. And the next thing is, in order to save operational cost, reliability is pretty important. So if your systems are not reliable, you are using the same resources, but you are actually, like, not able to meet your success criteria. So in order to meet your success criteria, you will end up, like, spending more more money, might be in more infrastructure or more engineers. So it really depends on the use case that you have. And the last one is team morale and engineering productivity. So if you translate this to engineering, like, how an engineer feel during, like, for example, if I'm on call and I get 20 incidents in my on call in a span of 1 week, my experience is pretty bad, and I don't feel like, continuing or doing one more on call. So, and it translates to, like, team morale, degradation in team morale, and also, like, the productivity of my engineering, right? Like, I- if the same incident is, for example, like, repeating throughout, like, multiple on calls, then it's a problem that, like, every engineer is spending the same energy on that and we haven't resolved it. So it necessarily, like, wastes, it's unnecessarily wastes engineers time and overall contributes to, like, less productivity. So these are, like, um, general, like, importances of, like, why we need reliability. Let's actually go to, like, why it makes a significant difference, especially with respect to 0 to 1 products. So what exactly is 0 to 1 product? So products that move from conception to initial launch. So if you have an idea of, okay, creating an app that actually serves these many users, and you want to provide some sort of functionality on that, then that's, like, and you have the idea and you go and code it, and then, like, like, you do the product market fit, etc. So that is the 0 to 1 product. So a concept is bring to execution and um, rolled out as a product. And why reliability is really important in 0 to 1 product? Like, to build essential trust with early adopters and customers. So whenever you are actually going and selling your product, then the early adopters are really important to actually, like, pitch in your product. So to actually gain the trust from them, it's not only just, like, bringing the business initially, but it's also, like, continue, like, maintain maintain that trust throughout is also important. So, and early adopters are pretty important. So it's always, like, good to build trust with early adopters and continue the trust. Similarly, reliability problems can disproportionately impact team velocity in early stage products. For example, if you just focus on only, like, functionality, then and you end up like not focusing on any of the reliability, then the tech debt keep piling up. And like tech debt keep piling up, and no matter like even if you want to um, like any new member joined the team, that person has to still deal with this tech debt, and the overall productivity will be less and the velocity will be less. So it's really important to get that balance of like rolling out fast in early stages versus having like building reliable products. So it's really important to get that balance. And the third point is establishing reliability practices early sets a strong foundation for scale. So most of the times when like 0 to 1 products are like built up, then they have like 1 year, 2 year, 5 year roadmap. But in terms of planning, they have like all these like 1 year, 2 year, 5 year roadmap. But when it comes to actual execution, like writing the code and deploying services, etc., then most of the times it turns out that like the solutions won't scale to 5 years. So it's really important to have the reliability practices put into execution as early as possible, so that you can actually build strong foundations, so that you can actually like scale it for all your like 5 year roadmap, or it could be 10 year too. So those are the importances of reliability in 0 to 1 products. And okay, here is a quote: reliability is precondition for trust. So trust is the major thing in any business, or in like in any service. So reliability is the key to actually bring that trust. Awesome. Let's jump on to our core principles, core principles around reliability and also guidelines. So I have been talking about success criteria and failure scenarios, issues, etc. Right? Like, and every point I just mentioned would be different in the real business use case that you are dealing. But there are some factors that are common and like really like foundations for the reliability. So among these are uh, there are like around eight. These are eight examples, but that doesn't necessarily mean all eight are applicable to every service or every product. So it really depends on the business value that you are actually bringing. Like all eight of these might not be applicable, but you really have to decide like which one is the most one that actually uh, measures your success criteria. So let's jump on to like what are some ways to actually measure your reliability. So there are like SLOs, the most common word that you usually use, service level objectives. So these are some things like where the success you define the success criteria of your component or service or product. So this is like specific measurable targets for service performance, such as, for example, okay, for if I have a social app, social networking app, then I can say 99.9% of the time my app is available. So that is the availability. So that is the SLO. Similarly, error rate. So monitoring the percentage of failed requests or transactions. So maybe like in the same social network app, when a user opens and user sees like splash error, then it's that considered as error. So other way to measure reliability is like what is the error rate at which the intended functionality is not working as expected. Similarly, like latency is majorly important in like velocity and also speed sensitive applications. For example, if you open an app, then it is taking like 2 minutes or 3 minutes. That's pretty bad. So the latency is really important, especially for user experience related applications, and also some financial applications as well. Latency holds a critical like importance. And how do you measure usually these latencies are, there is something called P50, P90, P99. So P99 is 19, like if you take 100 samples, 99 samples actually like are above a number. So that is the P90s. For example, if I have a service and the P99 of the latency is 1 minute, then 99 samples out of 100 are actually like have like latency less than like 1 minute. So, so the next thing is recovery time. So issues do occur, and for example, like GitHub is down, right? So and it takes maybe like after 2 to 3 hours it came back. So the moment it went down until the moment it came back, that is the mean time between these two is the recovery time after the failure. And there are other ways, that is incident frequency. So what is an incident? So I have defined, for example, like SLO for my system, and I'm not able to meet that SLO because something is going on with my service. Then usually I open an incident, and then like I try to find, okay, why this is not working as expected. So why the degradation is happening. So that's when like one way to measure the success criteria of your service is counting the number of incidents that your service had. If the incidents are less, then that means like you are doing good, like you're not creating any incidents, that means there are no degradations. Data consistency. So data consistency is um, not applicable to all applications or services, but it is like pretty important for some services, especially like financial ones, where like for example, if I have an app where I'm taking customers credit card or like some financial information, and then I'm actually sending it to a third party, then I need to make sure that I'm not like charging the customer 2 times or 3 times. I should only charge once. So those are some like critical things. Like the data consistency is, it's not just making sure your service is up, it's also your service is also doing the things correctly functionally. So that is one example of data consistency. Load handling. So load handling is majorly important for mostly like infrastructure services are like usually pretty much track this load handling. So systems performance under various traffic conditions. So for example, if your system is able to handle 100 requests per hour, and if I send you 200, how is your system handling? Is it like just dropping everything, or able to handle out of 200 able to handle 100, or dropping all 200, or dropping 150? So that is the load handling. Like what is the load handling capability of your service or product. And the last one is customer impacting metrics. So this is true for most of the applications that have direct customers. For example, if I open an app, then I don't see the screen. Then I file a report that okay, this is not working. Then all these like piled up into supporting tickets, and then the business had have to actually make sure these tickets are correctly resolved and the root cause is correctly resolved. So that is one way to measure for business on how it is actually serving its customers by tracking the number of support tickets. So these are like just some examples where it's a mixture of like everything. Like some are important for financial applications, some are important for products, some are important for core infrastructural services. So it really depends on the use case that you have. You can adopt one or more of these. um, okay, so how do you achieve 99.9 reliability? So there are like some guidelines and also like principles that are like necessary to actually address the reliability structurally in any organization. So these are some things like that you can actually focus, right? At high level, like identify what are your workflows. For example, if it is a delivery app, or if it's a something like if it's a retail business, then the order creation is the critical, like the P0 workflow. And there are other flows like user logging in, etc., etc., and accessing some pages. And there is another piece like notifications. For example, if you order something on Amazon.com, then it actually sends the notifications, regular notifications to customer. Okay, your package is on the way, your package is already delivered, etc. So that is one flow, the notifications flow. So among all these, there are like the reason why we need to divide or segregate these into different workflows is, if you segregate and then like assign a priority, then you and your engineers have better idea about what is the what is the degraded performance. For example, order, like if Amazon fails to take an order, then that's a direct direct result in like reducing the number of orders and the cost associated with that order. So that's really important. That's a P0 flow. And notifications to customer. So if a package is picked up an hour ago, if I receive notification now, it is okay. It doesn't need to be immediate, right? So that is a P1 flow. So identify, like try to divide your functionality into like high level, like business use cases into these workflows and assign priority. That will give you um, leverage to actually things to focus immediately. Then the next thing is like dive deep into each workflow. So take a workflow and understand what all services are in the path. For example, if you log into some website, then it is in the back end, it is actually flowing to different services. There might be 100 to 1000, more than 1000 services sometimes. So there are like critical services in the path. Understand like what are the different services. And there can be like the types of services. Understand what is the type of the service. For example, some are synchronous and some are asynchronous. Synchronous ones are nothing but mostly like defined as a services, servers like HTTP or gRPC. Asynchronous flows are, for example, the notification that I mentioned. Notifications are like most of the times those are all driven by event driven architectures, where for example, if a delivery guy picked up the package, then actually it actually triggers the notification workflow to get triggered, so that it can send messages to customer. So that's the difference. So but when an order you have come to any of these retail platforms, then it is like a direct interaction of customer. It's not, it's the real time. So that is the difference, synchronous versus asynchronous. And understand the success criteria of each. So for example, for synchronous, as I mentioned, gRPC endpoint, if it can be gRPC service or HTTP service. It depends on like how that component is a component or service is defined, and accordingly define the success criteria. For example, if it is HTTP, then the error rates are mostly like 500 errors, 500 status code errors. So if I'm actually owning a HTTP server, then 200s are success, and 400s are where the client has actually did not give me enough information, or it's an invalid request. So I should not worry about 400s, but mostly I should worry about 500s. So understand that like what exactly is the error in your use case. Similarly, gRPC has similarly like unavailable code, um, where the system is like not functioning as expected. So try to depend on the status codes for synchronous ones, and you can use those status codes to actually define, okay, this is my error criteria. And so after doing all this exercise, then apply key principles to each service. So we will be talking about what are the key principles of reliability in the next slide. But if you are like, be it an established organization or a very, a very new product, it does not matter. Like if you focus on these high level like structural approach, then the results will amaze you. Cool. Let's jump on to the key principles of reliability. So these are like key principles around every issue, right? So detection. So how do you measure it? Mean time to detect. So the idea is, like what exactly is detection? So are you able to detect or identify every error scenario that you are seeing? that you are like that you are coming across. Of course, for example, like if I have, like if I'm receiving 100 requests in the last 1 hour, and if I'm not able to serve one, just one request, that is going to be like I'm available for like like I'm serving, like my availability will become 99. So is it okay? Sometimes it is okay, but sometimes it is not. If the one request that you lost is only costing you maybe like $1 or $2, it is fine. But if it is costing you 50% of your like total orders, like it really depends on the monetary value. So you need to measure it. But overall, the concept of detection is nothing but uh, whether you are able to two facts, whether you are able to detect or identify every failure scenario that you have listed. The failure scenario is okay, just now I mentioned, am I able to serve 99.9% of the requests that I am actually seeing? And the second thing is how fast you can actually detect or identify. So that's also really important. So an issue occurred, and if you realize it like after a day, then you are losing all the business value between that time. And if you are actually working at the degraded performance, which might lose you some money, it can be monetary value or trust. It really depends on the metric. The next key principle is mitigation. And we use like mean time to mitigate to measure this. And mitigation is nothing but whenever the system encounters an issue where it is performing a degraded a functionality, then upon like the mitigation is nothing but whether you are able to bring it back to the working state, like non degraded state, and how fast you are able to do it. So that is the mitigation. And the next thing is, once you mitigate it, then comes the resolution. So resolution is nothing but it like completely resolves the issue. It avoids all the cascading failures, and it tried to do some recovery techniques, which we will talk in a bit. And the last thing is prevention, the number of issues or errors per week. uh, for example, so prevention is nothing but whether I am like the intention of prevention is like make sure the issue would never occur in future. So that should be the criteria of prevention. So these are the four core principles around it. Any reliability related issue that you need to understand, so that you can actually like continuously monitor these for all the issues that you encounter, and then like come up with measures on how do you improve that. Awesome. So the next thing is, let's actually deep dive into with some examples on what are these key principles are. So the detection. So as I mentioned, it is like whether you are able to detect or identify the degradation of the system, and how fast you are able to detect that there is a degradation in your system's functionality or availability. And so that is detection. And how can you measure this? So for example, in a delivery app, then it's majorly, for example, like order creation is the major thing that you actually like the more, as I mentioned, right? For example, retail app, retail or some delivery app, then if the customer cannot create an order, then it directly translates to the monetary value, and it is the critical like P0 issue. Similarly, communication to merchant or notifications to customer can be like delayed. It is okay to send delayed ones, but it's always important to send some notification than no notification, but delayed notifications are kind of acceptable. So that really depends on like the use case. For example, if you are running very huge like infrastructure service, then every API that you serve might be critical. Every API that you serve might create a cascading failure. So it really depends on the use case that the system that you are serving, on how you measure the issue. So this is how you measure the issue. And once you measure the issue, the next thing is try to assign a monetary value associated with that issue to gauge the priorities. So for example, if delivery app failed to create an order, then it is, so you, like, for example, then if you are like customer cannot create an order on amazon.com or DoorDash.com, then it directly maps to money. uh, like the companies are actually losing the money on commission. So it's a direct impact on the monetary value. And sometimes the monetary value might not be direct. It can be like like a transitive or like indirect. It indirectly maps. For example, if on a social network app, then for example, if user failed to actually load the status page, then it gradually impacts the user experience. For example, if I open today and tomorrow, both days, if it doesn't work, then third day I might not even open the app. So if the same thing happened to a large set of users, then what happens is like the ads loaded to those users might be less, and the user time is also almost went to zero. That means no ads will be served to that user or the set of users. So that indirectly maps to monetary value. So most of the social network apps get their money from advertisements. So it's really important to measure the success criteria and associate it with monetary value, so that you know like what you are losing. um, then the next thing is how to measure the failure, right? So here are some ways, as I mentioned, like before, about the most common one is service level objectives, defining service level objectives. And there are other things like metrics and SLA. So let's see. Metric is something where you can actually measure something, that is called the metric. SLO is nothing but setting an expected value, some value around that metric, and that is called SLO. For example, if the metric is overall like availability of my service, in the last 1 hour, if I receive 100 requests and I rejected five. For example, I own a HTTP service, and then I gave five hundreds out of 100 requests and 95 200s. That means my success rate is 95% for the last 1 hour. So metrics or reliability is usually measured over a time, because it cannot be instant. For example, if I see a glitch in just in this span of a second, I should not be reacted. So it's always measured over a period. It can be a minute, or it can be even a second, or it can be over an hour, or it can be over days. It really depends on the traffic that you are receiving. And once you define the metric, in this case availability is my metric, then is nothing but, okay, my SLO is the availability SLO that I have for my service is 99.9% or 99%. That means I always make sure the success rate metric is greater than 99%. If it doesn't meet 99%, then my SLO is, I could not meet my SLA. So that is the definition of SLO. Sorry, I keep saying SLA, it's SLO. The next thing is SLA, agreement on SLO that could put a monetary value or fines, so that the business or the service actually takes the accountability of the SLO miss. For example, if I'm actually serving 100 customers through my app, and for a like and I made an agreement with my one of my customer that, okay, I will always serve my service with 99% availability. Then, and in one day I could not, I did miss that, and I served only with 95% SLO. Then that customer is going to come and ask, okay, you said you want to meet this, we had this SLA of 99% every day, then why are you not meeting it? So you need to pay for that, like 4% degradation that the service, for example, in this case, like I own the service, so I have to pay penalty. So that is SLA. And SLAs are mostly at business layer, but for now, let's always like try to focus on metric and SLO, especially for engineering perspective. Cool. The next thing is mitigation. um, upon an issue occurrence, like how fast you are able to mitigate the issue. So mitigation is nothing but like it can be like it comes by identifying like what is actually causing the degradation, so that is nothing but root cause. So for example, my if I'm actually on call and I see that, okay, and for example my customers are pinging me that, okay, like this is not working as expected, then I open an incident and then I dig into the root cause of it. Like I go and see like different aspects, or like I go into the deep dive and also the anatomy of the issue and understand, okay, what exactly is causing this. So is this caused by any regression that occurred by a bug recently introduced? So we move like we engineers put a lot of code daily, like contribute to the code base, and without knowing, like we do introduce bugs. It's common in the engineering life cycle, but uh, like understanding the root cause is important, like able to detect that, okay, this is causing it is important. So there are ways to do it, like within your code functionality you can actually put some like counters, metrics around, okay, this is going to success path, this is going to error path. So whenever an issue is occurred at high level, you can actually go into a deep dive how these counters are actually behaving. Are these counters going to more on error path or success path? So like there will be different steps on how do you actually go and address the root cause. So these are some ways. So it can be let's go back, and it can be a regression occurred by a latest bug introduced, or it can even be an existing bug where a new traffic pattern has been like started kicked off. For example, this mostly happens in 0 to 1 products, where try to onboard the customers or like users onto the apps or the platforms, and we put a lot of code, but due to some, like sometimes the launches might be delayed, then and the user will actually start sending the traffic maybe after a few months, and by the time the engineer might have already forgotten that the bug is already there. So it really depends on what it caused. Sometimes it can be like configuration change that actually caused like as I mentioned, like in some incidents are very big incidents, null pointer exception, right? So how do you like catch that is really important. So you go and take a look at the counters or logs and understand, by deep diving you understand that, okay, this is the root cause, and then comes the way to mitigate. So it depends on the root cause. So if the root cause is like the try to see like how the issue got activated, and most of the times there are two ways to do it: fix backward and fix forward. Most of the times industry practices fix backward is the preferred way, that is recommended way, but that's not the only way. Fix backward is nothing but, for example, if I introduced if I caused an issue because of a code change, then revert that code change, and like make sure the change is like you go back to the working place. Your service, for example, is running on version 1 and version 0 was working, and version 1 has bug. Mitigation is nothing but going back to version 0. So that is fixed backward. And it can be as simple as just reverting the configuration change, which takes maybe like few minutes, and rolling back the latest deployment that you have, as I mentioned, like V1 version of the code and V0 version of the code. And the other popular one is fix forward. You know the root cause and you know how to fix it. Then instead of going back to V0 version, go from V1, go like try to come up with a new version V2 where you have the fix ready. So that is fix forward. But the recommended way to actually reduce the impact of the degradation is mostly like fix backward. It's good if you can fix forward. um, uh, so yeah, and overall, the goal should be to mitigate as fast as possible to avoid reduced monetary loss. So, like every issue, as I mentioned, is associated with a monetary value. So, as like if you mitigate it in 1 hour, then like you lose less orders, or the user experience will be better within, like, is limited to only 1 hour. So if you do it like after 2 days or 3 days, then definitely the user experience is going to bad, the customer experience is going to be bad. The next part of the guidelines is the resolution. So resolution is nothing but like mitigation handles till the point where you stop the bleeding, right? You stop the issue from happening. But the resolution actually go to the next level, and it try to completely resolve the issue. So it can be like, what do you mean by completely resolving, right? The complete resolution may be like, because of the degradation there can be cascading failures. For example, like hanging threads, or like like incorrect servers, or delayed, like the customers, for example, customers did not get the notifications. For example, if the notification service is down, then customers did not get the notification. But like, you need to have the recovery mechanisms to get the actual loss. Like, how can you recover the loss? Is comes with the resolution. For example, instead of like during so if you mitigated your issue for 1 hour, and you did not send the notifications to customers in that 1 hour, then after 1 hour, once you mitigated, try to replay the notification requests to the customers, so that at the end the status will be delayed communication than no communication. So that's the intention of like resolution. So you resolve it gracefully, and you resolve it completely, so there are no like hanging or incomplete like statuses or servers. So that is the like resolution. And it is really important to actually spend time on resolution as well, to actually get a better user experience and customer experience. um, yeah, so overall, this is also like, try to be as fast as possible, so that you can actually protect your business and monetary value. In terms of resolution, prevention, um, this is the last thing that is kindly like different to the three accesses that we have seen. The three accesses were detection, mitigation, resolution. Those three assume that the issues does occur, which is true. But prevention is something that tries to focus on how to avoid the issue next time, which is very important. So whenever you come across an issue, you detected it fine, you mitigated it back, and you made sure all the cascading failures are done. Good. But how can you make sure that incident would not occur again? So that is pretty hard. It's definitely not as easy as I said. It comes with its own challenges depending on the functionality that you are serving. So some common ways to actually address this in applications, it can be infrastructural services, or it can be apps or retail apps. So some things are like improve testing. So equip any change with unit tests and integration tests. Make sure you have your engineers are well, like your engineers and engineering systems. I don't say just engineers, but engineer systems are well equipped with testing. Some ways are unit testing and integration testing. And challenges could be like for unit tests, right? Like, it's always hard to think through all scenarios ahead of 0 to 1. Try to leverage some automated testing suites that are available, and try to make sure you do exhaustive testing as much possible, and detect the issue early before it goes to production. So this is really important. So if an issue was not caught in the unit test, whenever I put a code review, for example, and I enabled a code coverage on that. So code coverage as 99%. So all the code that I have latestly produced should have 99% coverage. So that is one way to actually make sure I have the testing. Once that is done, then we actually roll that code to the version, right? The latest version. Like, you build a version of your latest code, and then you deploy it to the server, so that your code is actually in production. So before just going to production, when you have the version that have your latest change, make sure that version is actually works for production traffic. So one way, how do you do that, right? Instead of directly putting in production, try to have a canary Canary way is not like is the most standard way that is used in industry in most of the companies, like be it like any big scale companies that you take. Canary notes are put like during the deployments, so that the canary is nothing but you have the latest version with the latest code, and in the production you have the working version. For example, working version is v1 and your latest version is v2. Try to run production traffic of, for example, like 1% production traffic onto this canary, so that, and get the results and compare it with the production v1 results. So like how do you compare? It really depends on, like, sometimes you can just run some scripts, goes and verifies the like the differences between the outputs. And so once you know that it is like the success criteria is like the match rate is like 99%, or you need to set, you will set a some limit on that 90% or 99% match, then you are good. Sometimes the difference is kind of understandable. For example, if you are fixing something, the functionality wise you are fixing something on v1 and v2, like there is a key difference between, okay, for v1, for api 1, the result is supposed to be 1, but in you fixed it to be 2, then the difference is kind of expected. So in those scenarios, like, you need to understand the differences are valid or not. So that is how you use canary. And ultimately you need to revert back to previous version working state if the parity is missing. So that is the intention of, like, this canary also actual, like, the live traffic testing. So this is how you prevent. So these are some ways on how you can actually, like, take a stab at prevention techniques. Cool. Let's actually put our theory into an action for 0 to 1 product. This is like majorly important for 0 to 1 product because, and you can, like, this is always adaptable to the established services too. But this is critically important for 0 to 1 because this analysis has to be done um, more often, like often for 0 to 1 product, because in this quarter I have, for example, features 1 2 3, and in next quarter I might launch 4 4 5 6 as well. Then the reliability criteria might be changed. For example, if the feature 4 has more monetary value, then I might include feature 4 to my list of p0 functionalities. Similarly, if feature 6 has like p1 priority, then I will add that to p1 list. So it's always like reiterating on what is your current state of 0 to 1 product, and then how you change or adapt the reliability techniques accordingly. So this is like how you can actually go and do some sort of exercise as an engineer. I consider, go and take all the sevs that occurred in either last 3 months or 6 months, all as sev zeros and sev ones. So keep a goal that none of the incidents should repeat in future. That should be the high level goal. Dig into the details of every incident with respect to the key principles that we just talked about: detection, mitigation, resolution, and prevention. And is doing this will identify detection, mitigation, and resolution and prevention gaps that your system, service, or product has. For example, I have a sev number. Sorry, I have a sorry. Yeah, I have a cell where that says app is down for Asian customers. Then I need to understand. So that is a high level like issue that I have detected. Then that means you need to go and write, okay, for that incident, like, what is the detection time? So whenever, like, when does the error spike started going up, and when did your alert got triggered? So detection is majorly like defining SLOs and creating alerts around that, so that the engineers get alerted and the business people get alerted about the degradation. So when did the alert get first triggered? So from the moment the degradation started, from till the moment the alert is fired. So that is the actually mean time to detect. So sometimes it can be 5 hours, and sometimes it can be a few days, especially for 0 to 1 product where the traffic is kind of um, Like we expect some traffic from our customer today, but the launch is delayed, it happens maybe after like few days. Then you will only detect like some things, you will be anticipating the traffic to be after some days, and you don't know when that is. So in those scenarios, the detection times will be pretty huge. The most of the time the detection numbers are huge, especially for 0 to 1 product space, because the success criteria are loosely defined and the traffic patterns are pretty like uncertain. So that is the detection. And similarly mitigation, so once you detected the alert is triggered, like how fast, for example, if this is like app is down in Asian area, and I identified that I rolled out a configuration change for only that caused only Asian customers to be impacted, then I just immediately revert back. 10 hours is too much, but I just put it as a sample. So usually if it is a configuration change, then I'll just revert it within few minutes. So that is the mean time to mitigate is nothing but by the when the from the moment the alert is triggered till the system went back to the working conditions. And the next thing is resolution. So once I made sure the mitigation is done, and did I make sure, for example, if during that downtime, most of the Asian customers, for example, like could not like pay, or could not like access some functionality, how do I make sure I can provide, like is there a way I can get back those, like I can log somewhere those transactions, and then like run some offline job or something where I can actually complete those payments, for example. I'm just giving you an example. So that is the resolution. And prevention is like, how do I prevent this? So we will talk about more. So one way to prevent this one, like app is down for Asian customers, is before you roll out the config change, for example, the root cause is config change in this case. Um, so before you roll out, are you doing incremental rollout, like instead of just making it like 0 to 100%, like can you like 0 to like make it like 0 to 10%, so that you can actually like identify it, so that the impact is not huge. And so the like one way is like with the incremental rollout with 10% of the traffic, you can actually identify the issue early, so that you can actually just go and you just roll it back to 0%, and then go address your actual problem. And then like that comes the next part of the prevention. So first, like get back, and then the prevention is like go and actually fix like why that occurred, and is there a way we can just avoid it. For example, is it's a bug, then go and fix the bug, and then like redeploy your service. So that is one. And once you do this analysis, so I just mentioned about analysis of one issue, and these sort of scenario, like do this analysis for all S0s and S1s that you received in last 3 months, and then like go and establish your goals, right? Like for sorry, for detection, like you need to make sure the MTTD values are certain, like within the certain limit. So most of the times the preferred ones are S0s and S1s should have less than 10 minutes, and MTTDs for S2s can be like 15 minutes. So S0s and S1s are like core are defined by the top businesses or top customers that you are serving, or top, like in top areas where you are serving. It really depends on the business. And the next thing is mitigation, like for config changes. If it is config changes, then you keep a limit on, okay, 15 minutes. You can like you should be able to revert within like 15 minutes. And if there is anything that is actually blocking that, then you go and fix your configuration system, that okay, I'm not able to revert it back within 15 minutes. Then there is a there is a follow-up work that you need to do in order to fix that whole aspect of, okay, I'm not able to fix a configuration change within 15 minutes. And for deployment changes, most of the time the rollbacks usually take an hour to two. And so set a upper limit on that. And resolution, always have a replay tools and recovery tools in place. For example, if I received 100 orders, for example, it can be for clothing or it can be for grocery, and record all the orders during the degradation, though you are not serving. record all the orders and grab, like, try to replay those orders. That way you are still serving. And replaying might be okay for some customers, might not be okay for other customers. For example, if I may, if I go to some like website and ordered and it gave me an error at that point, and at later time it says okay, your order went through, then it might not be a expected experience, or like desired experience. So it really depends on, like, the end of the day, like your, like how you are serving, like whether that is desirable or not. So go with replay and recovery tools as per your business and functionality needs. Can be as simple as a Python script or an automated job that runs these. So the next final thing is prevention. So set code coverage limits, as I mentioned, so that you can actually detect these early and then prevent it the going to production altogether. And identify, like, uh, all code reviews, so that you make sure like new code has like full test coverage. So those are some ways, but these might not be like all the ways. Like, this is not the exhaustive list, but um, I just took one example and then explained. So this is how you establish goals structurally. Like, you understand the reliability principles, and you keep your high level goals as okay. The number of incidents should be reduced is one goal, quarterly goal. And then I go, like, how do I do it? I go and I revisit all the incidents or issues that occurred in past quarter. And then with by using the reliability guidelines, I analyze each of these accesses can be improved or not. If yes, have a plan and establish tangible goals in terms of, like, all these accesses, like detection, mitigation, resolution, prevention. And do this process at least like every 6 months, especially for 0 to 1 product, so that you are you're keeping track of all the new launches that you have, all new features, that is not actually like degrading the existing reliability. Reliability is not something that you can just stood up today and then like forget. It's a continuous effort, because it directly impacts the trust with the trust with customers and also users. It's really important to, it's a continuous trade that any business or any system need to maintain. So that is the session for today. Any questions? Oh, you are on mute.
Oh, I'm sorry. I'm sorry. Yeah. I just wanted to let you know that the session was really good, and I just want to thank you for sharing all your incredible insights. We have a lot of questions. People have asked them in the Q&A section.
Okay.
I'll start.
Yeah.
Looking back at your experiences at
Mhm.
DoorDash, Meta, Amazon, and Nvidia,
Mhm.
how have your approaches to scaling and reliability evolved over time?
Definitely. So for example, when I was working on Amazon, and I was not I was not like senior engineer at that time, but I used to focus only on functionality when I started, and how I add value to the core business, right? Core business that my team is actually delivering. So I used to focus only on that. But soon after, like, started owning a service on my own, especially in Amazon, then I understand, okay, how the team and myself are kind of owners, and how reliability, like giving importance to reliability, actually, like changes the perspective of how you build systems. So that I learned in Amazon. And when I moved to Meta after that, and it's a different game. Like in Meta, the scale is huge. And so everything comes up with a scale. So every it can be every code change or every configuration change that you make, you need to be pretty cautious, and you need to make sure all the guidelines that I spoke are kind of, like, you need to make sure you're tracking all those. And because the reach is going to be huge. So over the years, with the ownership that I started taking, my perspective towards reliability definitely changed. In some companies it is small scale, and some companies it is large scale, but always try to keep like one principle I learned over the years is always try to keep the 5 year roadmap in front of you when you are designing systems. Cool.
That's a great advice, really. The next question is, what's one thing you wish more engineers understood about building reliable systems?
Sorry, can you repeat the question?
So, what's one thing you wish more engineers understood about building reliable systems?
That's a great question. So usually, like how I approach is running learning sessions about reliability. Like there are some ways to actually, like, it's not you building reliable systems. It's the like enabling the whole team and whole organization building reliable systems. So some ways to do is give learning sessions about, like these are important things. So whenever, for example, if your team is actually launching more features, then make sure like have this, like, checklist, make all these guidelines as a checklist and make sure everyone is following the checklist. The other things that are helpful is a learning session in terms of like going deep in every aspect of this. For example, uh, analyzing the root cause is the most challenging part in any issue in any company. So try to give learning sessions, or like, or if you're a junior engineer who joined in a new company, then ask your mentors or ask your senior engineers about, give, like, ask for learning sessions about, like, like like let's schedule some learning sessions on, like, how to just go and like root cause some ongoing issues, like join incident channels, and ask them to have, like, one thing that helped over the years is having some sort of, like, the senior engineers in the team running these debugging sessions weekly ones, so that the new members can join or the on calls can join, and then they can actually, like, they ideally they should not hesitate to ask any question even if it is small. So that's how I enable the whole, organization, or the like set of teams, with like the aspect of reliability in mind when building systems.
Yeah, I think asking questions like to a person that like even I am a junior, so keep asking questions is the best advice that anyone can give.
Yeah.
Okay, the next question is, how can you mitigate service success threats like outages from third-party dependencies?
How do you mitigate? That's a good question. So if a third party is if a third party is down, it's a hard problem. For example, if I rely on something that, for example, Google payments or Stripe payments or some, I'm just coming up with some examples. Then it's hard, right? Like it's definitely hard. Uh, the best way is asking them to actually, like waiting till the system gets back. And the other alternative approaches are, don't just rely on one service, have a fallback. For example, if it is payment, maybe have both Google and Stripe. That is one way where you have option, like, and having both Google and Stripe, both going down, the probability is pretty less. So try to have backup, and backups might not be possible in some scenarios. So in those cases, maybe like, um, like, establishing the service level agreements, as I mentioned, like, which has the monetary value, then the third party services will be more, like, are more um, desired to resolve the issue fast as possible.
Hmm, nice.
Yeah.
Okay, so what significant career lessons led you to your current senior engineer role?
What significant career lessons
Yeah,
that I learned?
yeah. And what led you to your current role, like the senior engineer role?
Yeah, definitely. Like, so one trait I have been carrying since the beginning is like ownership. Be it a very small functionality, or be it a service that your team owns, or one of the services that your team owns. Like initially, like in initial, like in the beginning of my career, and also like till I become the senior engineer, I used to be like more curious, and also like try to be like owner, like end to end owner. Okay, if anything happens, okay, I'm responsible. So that sort of attitude kind of gives you to know like what are ins and outs, then ins and outs of like your ownership territory. And then that will also give you, sense of kind of like leadership. So like leading a service. So it comes with multiple things, right? Like you need to make sure the service is working all the time. It can be reliability or it can be functionality. Um so yeah, be an owner is what I advise.
Nice. Okay. What skills are needed for a career in reliability engineering?
I think if you are the skills that are required are majorly like going, and if you're enthusiastic about debugging, uh, and you should be able to have the mindset of, okay, I will deep dive, I will go to the bottom of the issue to understand what exactly is going on. So you need to have that mindset. And skills wise, I think there are like a lot of third party tools. If you go for metrics, to define metrics, there are like third party tools like Chronosphere is there. And to get alerts and pages, there is something called pager duty. So for logs, there are like a lot of companies like Scalar Logs are there. Like there a lot of companies have inbuilt logging systems, but Scalar. So I'm just mentioning some third party tools that you can actually get up leveled on your skills to get a career in reliability. So these are some. And Google SRE, there are like a lot of books and videos on Google SRE engineering. So that's best way to get on boarded to basics of reliability and engineering.
Nice. I think these are all the questions that we had. And people are just requesting for the presentation as well. Like if you could share that later so
Yeah,
that we can share it
definitely.
with everyone. Yeah. All right. I
Awesome.
think if anyone
Awesome.
has any other questions, they can share it with us or probably unmute and then speak it as well. That's fine.
You're Pradnya, right? Thank you, Pradnya, for actually hosting this. And
Yeah.
it's great interacting with you all. And I really thank Creator to give me this opportunity, so that I can actually, a channel to actually empower like women engineers. So I learned a lot from my mentors. So I want to give back to the community. Thank you, everyone.
That's so nice because even I, built on this thing that giving back and learning from the mentors, and then once you are there, and then you also need to give back to the juniors and anyone who is starting in their career,
Yeah.
especially this women tech that we are trying to uh, bring on more women as much as possible into this tech industry. That's really nice. Uh,
Great.
I would like to reiterate that if people can uh, share that, sorry, what is it called? Feedback survey, if you can fill that up, everyone, that would be really grateful. And at the end, all I would like to say is thank you so much, Sandhya. This has been a really incredible experience for us. And all that you shared with us has been really inspiring. And I'm sure everyone here has gained valuable takeaways and they can apply in their own work. A big thank you to all of you who has joined us today and participated in the discussion. We hope to see you at our future events and have a wonderful day. Thank you.